Okay, and the last thing that we're going to do here is we are going to graph linear relationships. So example 1 from a formula. Sound travels 1,500 meters per second in salt water. The relationship can be expressed by the formula d is equal to 1,500 multiplied by t, where d is distance traveled in meters and t is the time in seconds. Make a table of values, use integers only. Okay, so we have our table of values now with time and distance. This was created just by plugging in this into here. So now we need to graph the ordered pairs. Okay, and then graph, we can see that this is distance in meters per 1,000. So I could kind of shrink the graph a little bit. And would it be reasonable to have points in between? Like, could I connect these points? Well, yes, because the next question that we're looking at is calculate the distance sound travels in 3.5 seconds. So then we plug that into our formula. And that leaves us with 5,250 meters. Okay, next one. Graph from a linear equation using integers, so positive and negative values. So let's look at this. We have our equation, so if we have an x value and a y value, let's choose -1, 0, and 1. These are like our key ones that we usually deal with. So 7, 4, 1. I don't have a negative yet for y, so I'm going to do one more, and that'll give me -2. Okay, and then graph it. Okay, so that's graphed, and determine the value for y in the ordered pair 11y. So this kind of jumps back to what we did in that missing value section. And all we have to do is y is equal to -3 multiplied by 11 plus 4 is equal to -33 plus 4 is equal to -29. And we could extend this guy out to prove that is accurate, but with our arithmetic, we should be fine. You have practice next and an assessment available for you to hand in.